Alright, what I got here are solutions to perfect problem 4 for Math 243. The basic idea here is we are trying to illustrate the central limit theorem. So I created these lists of data. List A is just some data. It'll turn out that this is right skewed, is what we'll end up seeing here. And then I created list B by randomly choosing observations from here. Pick 2 of them, average them out, that gave me this value. Pick 2 more, average them out, this value, and so on. And then list C, I did the same thing, except instead of choosing 2, I chose 10 from list A and averaged them out. So what we want to do is, well, I guess just kind of following these steps. First, you want to calculate list A's mean and standard deviation. So let's start with that. So the first thing you want to do is put all your data into lists. I have a separate video on how to put data into lists, so I went ahead and did that already. Here's list A, here's list B, and here's list C. And then it wants the mean and the standard deviation. So the way we can figure out the mean and the standard deviation is your calculator can calculate those. If you hit the stat button here, and then go over to calc, it's under one variable statistics. And we want to do one variable statistics on L1 because L1 is list A. And what it tells me is that my mean X bar is equal to 46.3-ish. We round it off to one decimal place, and our standard deviation is 47.8. Again, rounding it off. So okay, mean and standard deviation doesn't really mean much now. This is the average. This is some measure of spread. Okay. Then sketch its histogram and comment on its shape. To make the histogram, what you do is you go under stat plots, and turn it on first of all. And it looks like the histogram is this third type here. This is the one that looks like a histogram. Tell it what list your data's in. Mine's in L1. And then you have some options. You could do zoom stat. So hit zoom and then the 9th button. And it'll kind of guess what you want your bins to be. So this is the calculator guessing at what it wants my bins to be. Or you can hit window here and tell it what you want them to be. Like maybe I want them to go from 0 up to, my biggest observation is 225. Sure, so let's go up to 250. Maybe by 25s. I bet that will be enough. You can choose whatever you want for the bins, so these are just suggestions. If you then hit graph, it gives you a histogram. Here's my histogram. So, I don't know, I guess just histogram. And then I'll say bins equal 25. Your picture may differ. Because I didn't tell you what size bins to use. So using different bins, you get a different picture. Anyways, my histogram. You can kind of trace them here to get some idea. From 0 to 25, I had 13 observations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, way up here somewhere. And then from 25 to 50, I got 8 observations, then 3 observations. So maybe this is 8-ish. This is 3-ish. I got 3 again, then 1 in the next 2. And then 0, 0, 0, 1. Okay. 0, 0, 0. And then this last guy here, I had 1. Sure, here's my histogram. Looks good. Does it want me to talk about the shape? And comment on its shape. Okay, this would be very right skewed. You can kind of picture this as a curve. Most of the observations are over here on the left, but it has this really long tail out to the right. It's very right skewed. Okay, nothing too interesting yet. But now we're going to repeat that on list B and C to illustrate this central limit theorem. So for list B, let's see if I remember right, I calculate the mean and the standard deviation, compare them to what they should be, and then make a histogram. Okay, so I'm going to go through those same steps. I'm going to go stat, calc, one variable statistics, except now I'm going to use L2 instead of L1. And what it tells me is that X bar is 49.3. And the standard deviation was 35.3. Let's see, I expected X bar to be the same from list A because I'm just pulling observations from list A. The average of the averages should just be the average. I expect 46.3. And for the standard deviation, what I would suspect is not this same standard deviation of 47.8, but 47.8 divided by the square root of n, how many of these observations I'm averaging out to get each of these observations. In this case, it's 2. So what I expected the standard deviation to be would be 48.2 divided by the square root of n, 2 in this case, and I get this 33.8. So what you see is X bar is not exactly what you expected, nor is the standard deviation. Maybe this is the end of a sentence. Both X bar and S are relatively close to the expectation. If we had more observation, well, I'll just leave it at that. They're pretty close. Good enough. The central limit theorem looks like it's working. Now what we want to do is sketch another histogram, so we go under stat plot again. Same type, histogram, but this time instead of telling it my values are in L1, I'm going to tell it my values are in L2. And then, I don't know, I'll try using the same bin size, see if that's good enough. Sure, that looks like that works. So my histogram, roughly speaking, I can even look at it over here from 0 to 25. I had 10 observations. From 25 to 50, I had 8 observations. I only had 4 from 50 to 75. And then what? 6, 1, 1. Okay, so this guy is a little higher, something like that. And then these two are pretty low. These are down here at 1. And that's all of them. Here's my histogram. Still skewed. Still right skewed. But maybe not as bad. All right, this is very skewed. This one, it's not normal yet. We're getting there. It's still skewed. All right, one more time. Let's see. Repeat those same steps. Stat, calc, one variable statistics, L3. Get X bar is equal to 43.7. And my standard deviation is equal to 14.4. I expected the average in list C to be the same as the average in list A, which was 46.3. And I expected the standard deviation to be not the standard deviation from A, but that standard deviation divided by the square root of 10, because these are averages of 10 of these observations. So what I expected was 47.8 divided by the square root of 10, which is 15.1. Again, both X bar and S are close to expectation. Not exact, but not bad. 15.1 versus 14.4, that's pretty close. 46.3 versus 43.7, that's not horrible. Okay, histogram. It's under stat plot. Same type, except now my values are in L3. They're going to be closer together now, so it might not make sense to use that same bin size. Yeah, you can't really get much information there. So maybe let's reduce our bin size. Largest observation here, I don't think it gets up to 100. So let's go from 0 to 100. and maybe make my scale just 10, like the bin size is 10. Let's see what that looks like. There we go. So here's my histogram. I can trace them. See, it looks like I have 9 in that bin, which is the most. So my first bin, from 0 to 10, I had nobody. From 10 to 20, I had nobody. But from 20 to 30, from 20 to 30, I had 5 people. And then from 30 to 40, I had 9 people. And 40 to 50, I had 7 people. Then I went 3, 5, 1. You can probably remember those. 3, 5, 1. And then that's it. Then nothing above that. Starting to look approximately normal. Maybe that even gets an exclamation point. Yeah, I know this isn't approximately normal, but we're starting to get there. It's a lot better than this thing up in red here. Your book uses 30 as the cutoff for n to say, all right, it's approximately normal, good enough. We've only gone up to 10 here, but we can see it's getting better, right? This was bad. This was it was all right. This one's pretty good. This is what's called the central limit theorem in action. And we've seen that our values for our expectations for our standard deviation are relatively close, and that our histograms, the shape, are starting to get there. And so hopefully that illustrates what the central limit theorem does.